This conference will now be recorded.
So in the previous sessions of the basics of Unix, we have done with most of the basics. Now, probably today we will have the last class on Unix basics, and tomorrow onwards we will start working on Linux topics. So we have done with links yesterday. We have seen grep command. We have seen filter commands like less, more, head, tail, sort, and cut. Now I would show you another command, that is sed command. Now, honestly speaking, sed itself is a very detailed concept, right? That you will be getting more detailed when you watch the shell scripting stuff, what I'm going to share you after some classes. So anyway, one of the most important usage of sed command I'll be teaching you today. Sed is also a file editor. Like in Windows, we have Notepad. In Linux, we have VI editor, VIM editor, right? Isn't it? So same way, sed can also edit the file, but not exactly the way how VI editor or Notepad work. It opens the file, you take the cursor to a specific place and make the change. That is what we are not going to do with stream editor or sed command. See, in other words, sed is also known as search and edit concept. That means using sed, you can search anything in a file and replace it with something else. So it's like finding and replacing. I hope you might have done this with Word file, I mean MS Word or something, where there is a feature to search and edit a file. Same way, here also, you can search something and in place of that you can put another word. But the beauty of sed command is it won't directly edit the file immediately. It first show you the preview. Now, if you like the preview, you want to go for it, then you can make the change. So it won't apply the change immediately. Let us log in into our machine. Let me first see our Linux machine is up. Yes, it's up and running. So let me take the putty tool to connect to my Linux machine, which is 40, and I got connected. Let me log in as a user root and I'll give a password. Okay, so now I have logged in into this particular machine and I can see there are lots of file available here, hard, my file. These are all files, as you know. Now let me try to see one of the file. Maybe I'll try to see a file called hard. Now in this file, I've got a word called world. Now let us say that I would like to change that word and replace it with something else. So how can I use sed command to go to a specific line and or not specific line, at least find that word for me first of all, and then replace it with other word. Now guys, just imagine you are writing a shell script. What is shell script? Shell script is used for automating your work. Maybe you have a machine, or maybe in the current machine, you want to run a script. It should check the file and make the changes in the file according to your concept. Now, do you think that shell scripting can open a file in VI editor or Emac or Nano editor, Notepad kind of thing? And can it go to a specific line, go for I, press insert, then change, then press escape, save and quit? Do you think all that thing is possible with a script to do when you're automating the work? Absolutely not. So in this scenario, if you want to edit a specific line, only sed can help you. It search for a stream and replace it with something else. How it works, let me show you. We go with sed command. After sed, you need to use single quotes mandatorily. Without using that quote, your command will not be completed. Now over here, you need to use an option S. Treat S as search for something. Now what is the word you're looking for? I'm looking for the word called world. And this word I want to replace with another word. What is that word? For example, I want to say hello class, right? Instead of world, I need some other word that is called as class, right? And give a slash. So we need to give search, then slash, the word, slash, the new word, and close it again with slash, followed by a single quote. Now, which file you want to make the change? I want to make the change in a file called heart. So you see, earlier, the first line was having the word called word, which is now replaced with a new word called class. So that's how you can search a word and you can replace it with some other word of your choice. Not only this file, but let us say I have one more file over here, my file. Now in my file, you see there are some data mentioned. Now over here, there is a word called, for example, editor. I want to replace that word editor with some other word. Or maybe there is a word called test. I want to replace it with some other word. So I can say said, again single quotes, and you can say S substitute. Actually, S stands for substitute, but for better understanding, I'm telling search and replace, but actually it is substitute. Substitute in place of test, a new word. For example, this is command, right? I want to replace. In which file? The file name is my file. So you see there was a word test which is replaced by command. Now as I told you, the most good thing is it does not edit the file immediately. What you are seeing is a preview. There is no real change happened in your file. If you just reread your file one more time, you see the word test is as it is. It has not been replaced by any other word. Now, once you perform the set command and you got your desired output, now you really want to insert that change into the file. You want that change to be taken place. So what can be done in that scenario? Repeat the same command by using -I, where I stands for insert. Now guys, when you have instructed to insert the change, it is not going to give you any preview. That change will take place in your file. So first of all, run the command without -I to observe what change it is trying to make. If you are happy with the preview, then go for it with -I and now read the file. You see earlier the same line was having the word test, which is now replaced by another word called command. So that is how your set command is going to search anything in the file and replace it with some other word, whatever you want. Now inside it, if you want to replace all the words that is starting with editor or something like that, for example, in this particular file, you can see that there is a word editor repeated twice or thrice, right? So what I want to do is I want to replace all these words. So you can say said, search for the word editor, and you can add some other word in place of that. For example, you can say VIM software something, right? And I want to make the change global. Global means wherever the word editor is found, replace all of them. In which file? The file name is my file. So you see wherever the word editor was found, it has been replaced by the word called software. So this is the way, guys, how we can work with this set command, right? So as I told you, when you go for shell scripting stuff, you will learn a great detail about how to work with set command, but at least as a Unix admin on the basic part, we should know this first usage of set command to search anything and replace it with other word in a file. Right? You do practice, I'm sure you'll get doubts, so come back to me on that, I'll let you know. Now, another very important thing, guys, what we are going to learn is IO redirection. Now, what does this IO redirection means? See, IO redirection is to capture the output of any command into a file. Most of the time it happens, guys, that whenever you are facing some issues and you want to troubleshoot it, you would like to capture the output like what we do in our mobile phones. We take screenshots and we share that screenshots with our uh, friends, or maybe whoever is helping you to troubleshoot the thing, or if you are having a license, you would definitely like to share it with the support customer care, something like that. So same way it happens in Red Hat also, that sometimes some commands would give us error, so they might ask you that, can you share the output? Now, screenshot might be a little screen, but capturing the whole output, like yesterday I showed you one command, lshw. Now, how much big output it has? List hardware. LSHW stands for list hardware. So this is going to list the entire hardware of your system. Now, it's a big output. So I need to capture this output into a file and save that file, share with email or something like that. So how can I run a command and capture the output into a file? This is nothing but IO redirection. So there are two methods of doing this activity. The first method, what we are going to see, is by sending the output using greater and double greater option. So do you remember, guys, in cat command we saw greater and double greater. Greater will create a file or overwrite the file. Double greater will allow you to append the data into the file. So similar to that only, we are going to have it. Let me show you how to use that greater and double greater than symbol to capture the output. Let's take the example of list hardware. Now, when I run this command, it will capture it will display the whole system information. But I don't want to see on my screen. I want to capture it. And by capturing, I want to create a fresh file with that. So you can use greater than. Just try to understand what is going on. You are telling this command that whatever output is getting generated, send that output to another file. Now, same like cat command, you have to be very, very careful that whatever file name you are mentioning, that should not be present in your current location. If you use any name like hard file is there, so it will override that file. So same like cat concept, you have to be careful. So I'll say list hardware and send the output of that command to a new file. What should be the name of the file? For example, out1. Now you see there is no file in my current location which is having a name out1. So I'm safe. It is not going to get overwritten. Let me hit enter. So command got executed and no output has been displayed on the screen. But now when you list out, you will find that there is a new file created with the name called out1. If you see what is inside it, so just try to read it and you will find it contains the output of the command what we have executed, lshw. So the output of that command has been captured and it was created in a new file called out1. Now that file I can take it and I can send it to Red Hat or someone, my SME subject matter expert, and he can view and tell me where's the problem with that command. So it can be any blah blah command in the system, not only this command, but you are running cat command or any other command, whatever you want, you can run. After the command, if you give greater than symbol, then it will send the output of that command into a new file or existing file. Now let us say that Um, I'll run a small command to capture two output. For example, I'm running tail command. Why do we use tail command? To see any files last few lines. So we have a file. Yesterday we saw that you have a file with 50 lines. I don't want to see all. I want to see just bottom or last few lines. So I'll say show me last 5 lines of a file etc password. Now I don't want to see that. What I want is I want to capture that output. How to capture the output? Greater than followed by file name. Now just be updated that if you use any name of the file which is currently existing, it is simply going to overwrite it. So don't give the name of the file which exists unless you want to overwrite it. I don't want to overwrite a file, so I'm giving a new file. I knew that there is no such file with the name out2. Now, if you do ls to list out, you'll see that a new file created with the name out2. How to see the content? Cat out2. Cat will display the content of the file. So you see it captured the last 5 lines of the file etc password something. Now I want to keep this output just a line below. I want to add some new output. I want to run one more command, and whatever output that command will generate, I would like to capture that output into same file. So actually I want to append the data into same file, adding more data into same file or more output into same file. So I'll again try out another command tail -3. This time I want to see just last 3 lines. From which file? Suppose there is one more file etc shadow that I want to read, but whatever output is getting generated, this output also I want to send into out2, but I don't want to overwrite it. I want to append the data. I want to add more data to it. So I'll say double greater than followed by the file name. So when you use double greater than, instead of overwriting, it is going to append the data, same like cat command. Now you read, you'll see that your previous data is as it is. It has not been disturbed. But in the next few lines, this data has been added. So this is the way how you can capture the output into a file. Either you can make a fresh file or you can append the data into existing file. That's your choice. Now there is one more concept what we can use to capture the output, that is called as T command. Now guys, T command will also do the same thing what greater and double greater has done. Then what is the difference? Why should I go for T command? See, the only difference between greater, double greater and T is T command will display first the output and capture it. You might have observed that whenever I ran the command greater than or double greater, there was no output displayed. Instead of displaying the output, it created a new file. It copied into the file, I'm sorry. Instead of displaying the output, it copied it into a file. So in my present scenario, parallelly, I want to see the output and same time it should get copied. Maybe guys, I'm running a script. When you run the script, lots of information will be displayed on the screen. So let us say I have a scenario that I don't know whether the script will run perfectly or is it going to display errors. So what I want to do is, at one hand, I want to run the screen. I want to run the script and see the screen, and same time I want to capture the output into a file also. So both the things I want to do. How it can be done? It cannot be done by greater or double greater. Greater, double greater will hide the output. So if you want to see the output and capture it together, then you have to go with T command. How to use T command? Let me show you. You can say, for example, rpm-qa, right? And you want to capture it. Normally, if you want to capture, you can say greater, and the file name. So it will create a new file. No output will be displayed. Just the things will be captured to that file. But here you can say pipe, then you can see T and the file name. What's the file name? Out3. Now again, be careful. If this file is already existing, it may overwrite the content. So as we know, there is no such file with the name out3. So we can ignore it and continue. So observe over here what will happen. T command will parallelly display the output and capture together. So output is also getting produced on the screen. After the command executed, you just check it out. You'll find that the new file out3 is captured. You just read it. It contains what? It contains the output of the command what you have executed. So what's the benefit of T command we got? T command will display output and capture it, whereas greater double greater will not show any screen output but simply capture the output. So if you are interested to see the output and capture it, then you have to go with T command. Okay, all right. Now let's move ahead and say if you want to append the data into existing file. For example, I have this file out2 which contains some data. Now I want to add one more output into it with T command, not with greater or double greater. With T command, I want to capture and display both. So you can say, for example, we have, let's use some different command. Let's say I wanted to use date command. What date command will do? It will display the date and time, right? So I want to display the date command and the output I want to add. T-A is for appending or adding the data into existing file. So I'm going to mention the name of the file that already has some data. So you see out2 contains some data. In the same file, I want to add the output of date command. So you see date command has printed on my screen. Now you read out2 file, you will see at the bottom the output is added. So T-A will append the data in existing file. Only T will copy the output into the file or overwrite if the existing file is there. So this is the difference between T and greater double greater. If you personally ask me, most of the time we prefer simply going with greater double greater. In few cases, it may happens where you are interested to see output also, then only we'll go with T command. Anyway, now let's come to our next command, that is find command. See, find command, as the name itself is suggesting you, it is used for searching files or directories in the system. Like in Windows also, you might have seen when you press F3, a search tab will open. You can type the name what you are looking for and it will search something for you in the system. Same way in Linux or Unix, if you want to search anything, then you can go with find command. Find will allow you to search a particular file or directory into the system. Now the syntax goes like this: find where you want to find. Now if you have a specific location, just type that location name. In that location only it will search. But if you want to search in the entire operating system, then giving forward slash is enough. When you give forward slash means what, guys? Root folder. Root means what? The entire operating system. So it is going to search it under forward slash. You can search with some options. What options? You can search a file by its name. You can search a file by its inode number. So when you search a file with inode number, if two files have same inode number, what does that means? That means it is a hard link. That's how you can search hard links related to any file. Then you can search a file by its nature. What do you mean by nature? A file can be a regular file, it can be a directory, it can be a link file, it can be um, socket special file, block special file, character special file, anything. It can belong to any username or it can belong to any group. So with these options, you can search. So let me show you how can I search anything. For example, I don't know where the file is, so I'll say find. Find me something. Where? I don't know where it is, so I'll mention slash. That means in the whole operating system, search a file by its name. What's the name you are looking for? For example, I'm looking a file with a name called SE Linux something. So it is going to search your entire operating system, and wherever the file with the name called SE Linux is available, all that files it is going to list out, wherever it might be. Now, guys, let us say that I am not interested in files. I want to see all the directories or folders with the name called SE Linux. So how can I search a file or a directory? So first of all, my search will be find in the whole system a name SE Linux. First condition I have kept. Then I'll say hyphen type. D. D means what? Directory. So I am more narrowing my search. I'm telling that look out for a word SE Linux, but it should be a directory. So now you see it is only going to target those particular things which are directory by nature. For example, if I say ls-ld etc SE Linux, what it is? It is starting with D. D means what? It's a directory. So like that, you can combine many options and you can search the things for it. For example, I would like to search a file by its inode number. So let us say here is my number. I'll say find in the whole system a file by its inode number. What's the inode number? This is the inode number. So it will search thoroughly in the whole system and tell you how many files are having the same inode number. If you find two files with same number, that means they are hard linked. So that's how you can search a file is having how many links or hard links, and where that links are stored. Same way, you can search a file uh, by its type and by the ownership. For example, I'm looking for a file in the whole operating system, or maybe I'll narrow my search. I'll say that there is a directory with the name called home. So I'm telling go to home directory. In home directory, show me all the files that belongs to a user called my user. Suppose in my system there is a user called my user. Maybe in your system there is a user called Aman or Farah or Satya or Shabbir. So I'm looking all the files that belongs to this user. Where I want it to search, I want it to search under home directory. I don't want to search in the whole system. I know that in a specific location I can find it. So it went to that location and it displayed all the files whose owner or creator is my user. Okay, so this is how it can search and bring out the things for you by using find command. So find command is actually used for searching something in the system and bringing into our notice. Now let's move ahead and let's see the last topic that ends our basics, and a very, very critical and very important topic, file permissions. But at the same time, it is very interesting also. See, file permissions are nothing but the access permissions, what you can give to people who wants to read the data into your file or into your directory. Now, these file permissions can be applied on Three levels. How many levels, guys? Three levels. What are those? Level 1, owner or user. Who is owner? The one who has created the file is called as owner of the file. So as a root user, you create a file, root is owner of the file. As my user, if I create a file, my user is owner of the file. Whoever creates the file is called as owner or user of the file. Then in our system, we have groups. Groups are what? Collection of users. Guys, every organization has teams, projects. So according to teams and projects, groups are created. Related user who are working in the same team will put into that group. So each file can belong to a particular user and group of users. So the one group of users will be here. Now the one who's not the owner of the file, the one who does not comes into the group of the file will be called as other. Other means rest of the other world. See, a file can belong to a particular user that is called as owner. It can belong to a particular group. So in a group, maybe I have hardly 4 to 5 users. So all those 5 users will be called as group member. Totally in the system, there are 50 users. So one user becomes owner of the file. 4 5 users becomes group owner of the file. Rest of 45 or 44 users that are present in the system or other groups that are present in the system will come under the category of others. Someone who is not the creator of the file, someone who does not belongs to the group of the file will be treated as other, rest of the other world that is present in the system. So three levels you can apply the permission: owner or user level, group level, and finally others. Then the last thing what we have to understand here is there are three types of access what you can give on a file or directory. You can give read access so that people can read the data what is present in the file. Then you can give write access. If you give write access, people can make changes into your file. They can add some data, overwrite the data, or they can also delete the content of the data, or entire file can be deleted. Last permission is execute permission. Now, execute permission is a special permission required in a special circumstances. What is that? We will understand in a while. So let's talk detail about these permissions and their effect on a file or a directory. So guys, if you apply read permission on a file, it will allow you to open the file and read the content of the file. Same effect is there on directory also. If you apply the permission on the directory, read permission, it would allow to list the contents of the directory. Like in this directory, how many more audio files, video files, whatever is present, people can just see by running ls command. Then we have write permission, as I told you. Write permission will allow you to write, edit, append, or delete the content of the file. Anybody can open the file, they can read it, write it, or they can make the changes in the file, or if they want, they can even delete the file also. Same thing is applicable on directory also. For a directory, if you give write permission, then people can add more data into the file directory. They can delete the contents of the directory, or even they can rename the content of the directory, or even the directory can be renamed or deleted. Right? So read and write permission both are having similar effect on a file or on a directory. Read will allow read access, write will allow changes in the file or directory. But execute, as I have told you, has a special requirement. On a file, it is not generally required. On a file, it is only required when the file is special file called shell script. See, whenever you have a file which is a script, to run the script, you need execute permission. Otherwise, on the file, execute permission is not that much important. Execute permission on a file is only needed when the file is a script containing lots of actions. But on the directory, it has very important role. On the directory, if you want to allow people to go into your directory by using cd command. See, sometimes I'll first go into the folder or directory and then I want to do some activity. So if you want people to go into your directory, they need execute permission. Remember me, my word, that on the directory, if you don't have execute permission, people cannot go into your directory. To allow people to enter your directory, we need mandatorily execute permission. Without execute permission, nobody can enter into directory except root. Root is admin and you cannot stop root user. Root can do anything, right? So execute permission has a different effect. On a file, it generally not requires to have execute permission unless the file is a script and you want to run the script. Whereas on a directory, it is very much required. Without having execute permission, people cannot go into your directory. Okay, all right. Now, let's see how can I apply these permission or remove this permission on a file. So there are two methods to apply or remove permissions from a file. One is symbolic method using symbols UGO, and the second method is absolute method using numbers. So what are these and how they work? Let's go and learn in a detailed way. First, we will do with symbolic method. So as the name itself is suggesting, that we are going to work with symbols. What are the symbols? Now here U represents user or owner, G represents group owner, and others represents rest of the other world. So how can I apply the permission? You have to say chmod. The command what we are going to learn is chmod, change mode. For whom? Who means you need to mention U or G or O for user, for group or others. Then if you are adding a permission to existing, you can use plus. If you are removing a permission from existing, minus. If you are totally changing the permission, then you can go for equals. Plus for adding a new permission, minus for removing existing permission, equals to totally change the file permission. Now, as of now, it may not be that much clear. Let me show you practically how it works. Now, if you take this file hard, for example, see guys, over here, you can see it is displaying file permission to you. Now, what you see over here, let me put it into a notepad for better understanding. One second. So over here, you can see the file permission is starting like this. Dash, the nature of the file. Then there is RW dash. Then again there is R, there are two dashes. Again there is R and two dashes. So what does this means? See guys, first three permissions what you are seeing over here, RW dash. This belongs to user. That means the creator. Who is the creator? Root user is the creator and root group is a group owner. So root is a username and root is also a group name. So anyway, first three permission belongs to creator, owner or user. Then next three permission what you see here are and two dashes that belongs to group. And last three permissions what you see here it belongs to others. So first three permission belongs to user, next three permission belongs to group and last three permission belongs to others. Excuse me for a moment, guys, just 1 minute. So as I was telling you that first three permission belongs to user, second three permission belongs to group, and rest of the other world is the last permission. So user is having read write, no execute permission. Group is having just read permission, and others are also having read access. So this is how you can find on a file what exact permissions are applied. Now let us say that I would like to modify this permission. As per my requirement, I want the owner to have full permission, read, write, execute. Group to have read, write permission, others let it be read permission. So how can I modify the total permission of a file? To change the permission, I'll say chmod whom you are trying to modify. Let's say I want to modify it for user. So I'll give u equals what permission you want to apply. I want to apply read, write, execute. So all symbols we are going to use. U represents user, R represents read, W represents write, and X represents execute. Then it's now finish. I want to continue for group and others also. So if you want to continue, give a comma and go for group. For group, I want read and write permission, comma. For others, I want to give just read permission on which file? On hard file. Now you go back and check the result. You'll find that owner is having read, write, execute. Group is having just read, write, no execute. Others are having just read, no write, no execute. So according to your requirement, you are now able to change the permission. And you see the color of the file has changed to green. Now, why the color changes to green? See, whenever in file permission, you have execute permission on any level, whether it is owner or group or others, any level, if you have execute permission, the color will be displayed in green color to represent that this might be shell script kind of thing. Okay, anyway, that's just a color. It is showing that the file is having execute permission. Now let us say, guys, that I don't want to totally modify the permission. Maybe my requirement is I want to remove write permission from owner and I want to add execute permission to others. So on one level, I want to remove permission. On other level, I want to add permission. How to do that? You need to use again chmod. Chmod command is used for changing the file permission, right? Right. So I'll say chmod on user level. I want to minus something. So I'll say from user, I want to take away write permission. But at the same time, for group, I want to add which permission, execute permission, on which file, hard file. So on one level, I am taking the permission. On other level, I am adding the permission. Now you just check it out. You will find from user, write permission is removed. And for group, execute permission is added, right? Or let us say I don't want to do two at a time. Maybe I just want to add execute permission to others. That's it. For others, I want to add execute permission. So you can say chmod for others, add execute permission on hard file. So you'll find that execute permission is added. So just by using the symbols U, G, O, RWX, you can add any permission or you can remove any permission on the file. Now let us say that I wanted to give full permission on the file, or maybe I want to give same permissions to all. I don't care what permission it is having. I want read and execute permission to everyone. So you can say chmod for all. In a simple word, you can say ugo equals to, and you can say for everyone, I just need read and execute permission on hard file. So just see read and execute for user, read and execute for group, and read and execute for others. So for all of them, you are going to get same set of permission. Or let us say for everyone, I wanted to have just read permission. So you can say chmod. One more method. Instead of typing ugo, the shortcut is A. A means what? All. For all, I want just read permission. On which file? Hard file. So you just check it out. User is having read, group is having read, others are also having read. So this is the way, guys, how you can use symbolic method and apply whatever permission. Okay, what if you want to give full access? No problem. You can say for all, read, write, execute. So full permissions they'll be getting. One more thing, guys. I want to remove total permissions. You will be surprised that there are few files, very important files in the system that will not have a single access permission. What is that? We will learn one of that in the coming time, not now. So if you want to take away all the permission, no permission at all, then you can mention no read, no write, no execute. Three dashes means no permission, no read, no write, no execute. Now, if you just check it out, did you find any set of permission? Nothing. There is no permission whatsoever on the file. So nobody can read, write, or execute in this file. Observe the color. As soon as you remove execute permission, the color of the file change to black. So this is the way how you can make the changes in the permissions of a file using symbols. Now we have one more method to change the permission, that is numbers, which is very simple when compared to symbols, which is called as absolute method or numeric method also. So here we use numbers instead of names. Read is represented by a number 4, write is represented by a number 2, and execute is represented by 1. 4, 2, 1. Read, write, execute. Now let me show you the most interesting way to calculate these numbers. Suppose, guys, I have a requirement that for user, I want to give read, write, execute permission. So guys, read is represented by what number? 4. Write is represented by what number? 2. Execute is represented by what number? 1. Now just club them. 4 plus 2 plus 1. What would be the result? 7. Suppose for group, I want read and write access. So read is represented by 4. Write is represented by 2. 4 plus 2. What would be the number you will get? 6. Lastly, for others, maybe you just want read permission. So read means it is represented by what? 4. So what's the final number you have gathered? 7, 6, 4. Let me use this with chmod and see what happens. So if you want to change the permission of any file using number, you just say chmod, and what is the final value you gathered? 764. So I'll say 764. So first 7 will be applied for user, 6 will be applied for group, and 4 will be applied for others. On which file? Hard file. You just check it out. So first three permissions are read, write, execute. Next set is read write, and the last one is just read. So exactly the way what you have calculated for user full permission, for group read write, and for others just read. What's the number we deduced? 764. That's it. So you just need to have a calculation in the mind and you can apply those permissions whatever you want to apply. Suppose you wanted to give full permission on the file. So you can say chmod 777 full permission. So you see each level will get read write execute, read write execute, read write execute, full permission. You want to remove all permissions. So you can say chmod 000. Now you just check it out, all permissions are gone. Suppose you want full permissions to user, read permission to group, and read permission to other. So you can say what? You can say chmod 7 means full permission. Only read 4. Only read 4. On which file? Hard file. So you see read, write, execute, read and read. Right? So that's the way how you can use even these numbers. Now, in which situation it is better to use symbols and which situation it is better to use number. There is no good or bad practice, guys. Whichever you like, you can use it. But whenever you are changing individual permission, suppose from group you want to add one permission, go with symbolic method. If you are totally modifying the permission of the file and you want to do it quick, go with numeric method. So symbols are useful whenever you are adding one permission or removing one permission from the file. That place symbolic methods are useful. But if you are totally modifying the permission 764, 755, these numbers can make it very faster. So whatever you use doesn't matter, but both are possible. These are choices, right? So both can be useful in a better manner. Now let's learn the final topic, that is UMask. Now guys, I will create one file. For example, I'll create one file called mf1. Now if you check this file mf1, the file got created and automatically it had some file permissions. Read, write, read and read. Now guys, when I created a file, did I mention what permissions to have? Did I even told what permission to be used? I simply created the file, that's it. I never mentioned what permission to be there. So these permissions are called as default permission for a file. Now the question here is how it is getting that default permission on the file. Who is assigning that default permission on the file? That is the case of UMask. Now what is that UMask? See guys, UMask stands for Unix File Creation Mask. That means in Unix, whenever you create a file, this fellow is responsible for assigning default file permission. Now, how can I check UMask? To check UMask, you can simply use a command UMask. It gives you some number. What's the number? 0022. Now guys, I request you to ignore first zero and concentrate only on last three digits. I'll explain you later on why we are ignoring first zero and where that first zero is useful. So as of now, I just want last three digits 022. Now this 022 is responsible for your default file permission. How it is? Let me show you. See guys, let's calculate default file permission. Guys, whenever you see maximum, the file permission a file can get is 777 full permission. That is the maximum permission. But in Linux or Unix, there is a rule that no file by default can get execute permission. Normally, guys, when you see a viruses or any malicious things, they enter into your system with the help of these files and something. When you download some file, with the file, these viruses will come and they may affect your system. So these viruses are generally scripts, guys. When the script get executed behind the scene, they affect your system, they damage your system. So by default, when you download a file or when you create a new file or when you get a file from other sources, Unix will not give execute permission by default. You have to apply execute permission manually. So there is a rule that a file by default will not get execute permission. This is only for files. So a file is not allowed to get execute permission by default. Then what is the maximum permission it gets? Maximum permission it gets is 666. This is maximum allowable permission for a file by default. Now with this number, if you minus the umask, what's the umask? 0, 2, 2. So guys, it's a simple math. So we just need to do minus. 6 minus 0, 6. 6 minus 2, 4. 6 minus 2, 4. Now what does this means? So let's calculate it, guys. See guys, if you say 6, 6 is a combination as per the file permission values. As per the file permission values, 6 stands for 4 plus 2. 4 plus 2 means what? 4 means read, 2 means write. Okay. Then you have 4. 4 means what? Read. Then again you have 4. That means what? Read. So what is the permission you are going to get by default in this situation? You will get on a file, read, write, no execute. Just read, no write, no execute. And again, just read, no write, no execute. Now, if you just go back and say ls-l, are you witnessing the same set of permission, guys, over here? Read, write, read, and read. That's what the exact thing we have calculated. Yes or no? So whenever a file is created, full permission will be minused by umask value, and that's where you will get your default file permission. So umask is responsible to assign permissions by default on a file or on a directory. So on a file, the default file permission is read write for user, read for group, and read for other. Now let's find out if I create a directory or a folder, what would be the default permission, right? So let us calculate it. Let's put it up over here. Default directory permission. Now, when it comes to directory, there is no rule to get um, read permission or execute permission. I'm sorry. So maximum permission a directory can get is 777. See guys, for a directory, if you don't give execute permission, then nobody can go into the directory. Right? So for directory, it is allowed to have execute permission by default. For file, it is not allowed to have execute permission because it may be a script, and if script got executed, it may damage the system also. So no execute permission by default. Whereas for a directory, it is very important to have execute permission to step into the directory. So 777 is the full permission a directory can get. Now if you minus 0 to 2 umask value, you'll get default directory permission. So 7 minus 0, 7. 7 minus 2, 5. 7 minus 2, 5. So what does it means? It means 7 is equals to 4 plus 2 plus 1. That is read, write, execute. Then the next permission is 5. 5 means what? 4 plus 1. So 4 stands for what? Read. 1 stands for what? Execute. Then again you have the same calculation 5, that is nothing but 4 plus 1, which is read and execute. So what is the permission we have calculated here? It would be for user read write execute, then for group read no write but execute permission, right? Again read no write and execute permission, right? Let us create one directory and see how to create a directory. Mkdir, I'll say md1. Now you check ls-ld md1. Did you get the same set of permission what we have calculated? Read, write, execute, read, execute, read, execute. Did you witness the same thing? Read, write, execute, read, execute, read, execute. So umask value is responsible for assigning default file or directory permission. Now the next question is, can we change the umask value or adjust it to according to our requirements? Of course, you can do it. But if you ask me, does it happens regularly in working cultures? Not regularly. Rarest of cases it happens that you change umask value, but otherwise the default umask value is 022. Just concentrate on last three digits, ignore the first digit. Now if you want to change it, you can change it umask and I'll make it 044, for example. So now the umask value is changed to 044. Now obviously guys, in change umask will affect your default permission. So what would be the file permission now? Minus 044. So 6 minus 0 would be 6. 6 minus 4 will be 2. 6 minus 4 will be 2. So it would be read write. Then next is 2. 2 means what? Write permission. Again 2 means what? Write permission. So your default permission will now be changed to read write, write and write, right? Or maybe, sorry, read comes second. So it would be like this. This is the way it would come up. Read, write, write and write. Something like that, right? So this is the way the permission would be. So let me show you. Now let me create a file. I'll say touch mf2. Check ls-l mf2. What's the permission it is showing? Read, write, write and write. How about a directory? Same calculation. You can just come up over here and say 777 minus 044. So 7 minus 0 is 7. 7 minus 4 is 3. Here also 3. So what does 733? 7 means full permission. 3 means what? 2 plus 1. 2 means what? Write and execute. Same thing. 3, 2 plus 1, where 2 stands for write. So the file permissions would be read, write, execute, write, execute, write, execute. Let's create a directory mkdir md2. Check the permissions of md2 and you will find read, write, execute, write, execute, write, execute. So guys, whenever you change the umask value, automatically the default permissions will be affected. So change it, play whatever you want to play with the number calculated. But once your work is over, do not forget to change it back to default. What's the default? 022, right? So that is it guys for today's session. This ends up the basic session of Unix. From tomorrow, we are going to start working with Linux topics. So far, if you have any questions or queries, guys, you can put your questions now. Okay, it seems there are no questions, so that's fine. We'll stop the session here. Okay. Okay, Aman is having a question that is it mandatory to use that? See, what you are asking is this thing. This is showing what is the name of the user you are using for logging into the system and what is the name of the machine. So I'll share you the previous videos of the class as this is the first class for you. Maybe that question is arising. So if you see our previous videos, you will find out that we have kept the name of our computer as mlinux 40, and right now I'm working as a user called root user. So it is saying me that this is the name of the user and this is the name of the machine I am connected to for my reference. So it is only for display purpose. We don't use it, but it is showing what you are using and on which machine you are working. Okay, then we'll stop the session here, guys. Let's meet up tomorrow. Okay, yes, please. Anyone is having question? Yes, please go ahead. Our test machine, you can turn it off anytime. But if it is our production machines on which we are working, it is not recommended. Your Oracle VM box is your personal property. There is no production going on it, so you can turn it off. In fact, when you have asked the question, I'll tell you the most easiest way to turn off your machine is by running a command power off. When you run power off command, this shut downs your system. So in a while, you can observe on your Oracle VirtualBox, your machine will be displayed turn off. So just use a command. This is a Linux command, power off, and hit enter. The machine will be turn off. But on production, it might not be advisable because production is 24/7. So no on production, but your personal machines, yes, you can turn off every day. Right. Okay, guys, then we'll stop the session here. Do practice, guys. And before starting the session, also, you can put me the questions so I can answer your questions and then we can move out. Yes, thank you very much, Aman. We'll meet tomorrow.